Okay, today is November 30th, 2011. We're on lesson 6.3. We're working on laws of exponents today. So we have three major rules. The multiplication rule. We have multiplication rule. We have a division rule. And we have a power of a power rule. Okay? These are the three major rules we're going to use to solve these questions. I'm going to go through 4 examples relatively quickly. Very first example, we have a question that says 5 to the power of 4 multiplied by 5 to the power of negative 2. Okay? So this is a multiplication rule. It's a multiplication sign in between both of these. Now, I'm going to talk about the multiplication rule. What it says is 2 exponents with the same base. That's x and x. So the bases are the same. And in this question, we have 5 and 5. What you would do to simplify the question is if the two numbers or the two terms with the same base are multiplied by each other, you can turn it into one base and add the 2 exponents together. So in this case, what that means, we're going to simplify this to the base of just 5. And we're going to add the 2 exponents together. We have 4 plus negative 2. 4 plus negative 2 is 5 to the power of 2. Second example. Negative 6 divided by, negative 6 to the power of 2 divided by negative 6 to the power of 1. Okay. Now, this is a division sign, so we're talking about our division rule. Anything that looks like a fraction, what it really means is that line in between represents division. And the division rule says 2 exponents with the same base, this is where we have x and x. If they're divided by each other, we simplify to one base and subtract the exponents. Essentially the opposite idea of our multiplication rule. So, we have base of negative 6 and negative 6. We're going to simplify this to one base, which is just negative 6. And we're going to subtract the 2 exponents, which were 2 and 1. We get negative 6 to the power of 1. Okay, 1c. We have an exponent. We have a base to the exponent, and then to another exponent. So it's a power of a power rule, which we have over here. Okay? The power of the power rule says that if we have a term in the brackets with an exponent, and those brackets are to an exponent, you can simplify it by keeping the base the same and just multiplying the 2 exponents. So, we keep the base the same, we have m, and we multiply our 2 exponents. 5 times negative 3. M is equal to negative 15. Does that make sense to you guys? All right, we went through each of our rules. Now we're going to put them together. We have a to the power of 2 times a to the power of negative 5 divided by a to the power of negative 2 to the power of 3. So, before we start, I want to point out that we are actually encompassing all 3 of these rules right now. The top of this fraction have 2 bases the same that are multiplied by each other. So that's what we're talking about, our multiplication rule. On the bottom, we have a base and a power of a power. That's our power of a power rule. And those answers are divided by each other, so we'll eventually get into the division rule. 3 different things put all together. What I'm going to do is I'm going to solve the numerator and the denominator, which is the top and the bottom of this fraction first. Then I'll work with the division. So the very first, the top is dealing with multiplication. We have a squared times a to the power of negative 5. I'm going to keep it together as one exponent, so it's multiplication, and we're going to add the two exponents by each other. But that same idea, I'm going to also simplify the bottom a little. The bottom is a power of a power, so I can simplify it with the same base a, and I'm going to multiply the two exponents by each other because it is a power of a power. Our next line will read a. 2 plus negative 5 is negative 3. Divided by negative 2 times 3 is negative 6. I've now simplified this to just the division question. So we use our division rule. We know that we can simplify this to just one base, and we're going to subtract the two powers. It's very important in the division rule that you subtract the top exponent by the bottom exponent. So the top one goes first. Needs to be done in order. So negative 3 subtract negative 6. We have to know our integer rules. If we have two negatives beside each other, what can that technically represent? Yeah, we can make that a positive sign. So essentially what this says on the side is negative 3 plus 6. What will negative 3 plus 6 equal? 3. So we get a to the power of 3. Okay, example 2 says the number of hybrid vehicles sold in the US, which is the variable S. So S equals number of vehicles. Vehicles sold in USA can be modeled by this equation. S is equal to 199,148 multiplied by 2.39 N. So we have our equation modeling number of vehicles sold in the US. N represents number of years since the year 2005. So N equals number of years after, that's very important, 2005. Okay? Question A asks us, evaluate this equation when N is equal to 0. So we're going to look over at our new rules. I put two new rules on here, exponent and negative rule. Which applies to this? 0 exponent. So we're going to take our equation. S is equal to 199,148 times 2.39 to the power of 0. What will happen to 2.39? How do I evaluate that to the power of 0? What is that equal to? That's right. 2.39 to the power of 0 is equal to 1. Any number to the exponent 0 is equal to 1. So we get S is equal to 199,148 times 1. What is it equal to? Okay, now let's make sense of this. What does n to the power, n equaling 0 mean to us? What year are we in when n equals 0, Aiden? Matthew? Pardon? 2005. So because this equation, n is the number of years after 2005, if we're at n is 0, that means in the year 2005, there's 199,148 vehicles sold in the US. Okay? Okay. Question B says they want you to evaluate how many vehicles were sold in the year 2004. Okay? Now recall that n is equal to 2005. Number of years after 2005. So n is number of years after 2005. If we were to evaluate the number of cars sold in 2004, what does that mean our n is going to have to become? -1. That's right. We're going back a year. Since n is after 2005, and they're asking us for the year before, what we'll be doing is we'll need to take our 2004 and subtract 2005 in order to figure out what our n is going to be. Okay? In this case, our n is going to be -1. So I'm going to put that into our equation now. S is equal to 199,148 times 2.39 to the power of -1. Now I want you guys to look at this negative exponent rule we have over here. It says a base with a negative exponent can be represented by the reciprocal of that base. So essentially what it means is we put it below 1 into a fraction form and we make the exponent positive. So if we were to do that as a side calculation here, 2.39 to the power of -1, how else can I represent that as a positive exponent? We can represent this as 1 over 2.39 to the power of +1. Now, an exponent to the power of +1, is that going to change the number at all? No. It's going to stay the same. So we're going to get S is equal to 199,148. We're still multiplied by, but in this case it's 1 over 2.39 to the power of 1. Any number without an exponent is technically to the power of 1. So we don't need to include it. To the power of 1 is not going to change anything. Okay. Now, I can put each of these into my calculator and try to solve that. Or I can use fraction rules to multiply. If I was to use a fraction rule to multiply 199,148 as a fraction, just goes over 1. And when we multiply fractions, we multiply the top by the top and the bottom by the bottom. So we could change this question around. It becomes 199,148 divided by 2.39. Now we're going to put this into our calculator. 199,148 divided by 2.39. 83,325.5. So, how many cars were sold in the year 2004? Do we use this 0.5? Do you sell 0.5 of a car normally? Really? Sometimes? Maybe sell the parts to a car. I think they're talking about new vehicles, so we're going to actually round this down. Okay? If you don't sell a half car, so in 2004, 83,325 vehicles were sold. I'll probably with this word. V-I-V-E-C-I-C-I-E-S. We'll get to it. All right, 2C. They want us to predict how many cars will be sold in the year 2007. So we're going to have to predict what our n is going to be. Okay? Recall that n is the number of years after 2005. So what we'll do is we'll take our 2007 and subtract 2005. What will our n equal? +2. So we go to put it into our equation. S is equal to 199,148 multiplied by 2.39 to the power of 2 in this case. Now I'm going to evaluate this quickly on the calculator so we can get to some more difficult questions. 2, that's a good question. 2.39 squared, or to the power of 2, I'm going to keep that number and multiply by 199,148. In 2007, there were 1,137,553.2 cars sold. So in 2007, 1,137,553 vehicles were sold. Question 3a. We have a to the exponent of -2 times b times a to the power of 3 times b again. The very first thing I'm going to do is make everything a positive exponent. So luckily, 3 of these terms are already positive. What is this b to the power of? 1. So there's technically a 1 there. This is a negative exponent, so I'm going to make it a positive exponent. A to the power of -2 is equal to 1 over a to the power of 2. So now, because these are all multiplied by each other, luckily I can do them in any order. I'm going to get 1 over a to the power of 2 times b times a to the power of 3 times b to the power of 4. So I can actually separate each of these and then multiply them. Now I want to collect my like terms. I'm going to put my two b exponents beside each other and my a exponents beside each other. So we're going to get 1 over a to the power of 2 multiplied by a to the power of 3. And I'm going to get b times b to the power of 4. Our first one is going to be simplified. I have to multiply fractions. So essentially this is over 1. We multiply top numbers by each other and bottom numbers by each other. So I'll get a to the power of 3 divided by a to the power of 2, which will then be multiplied by b times b to the power of 4. Now I want you guys to recognize this. This here is our division rule. We're using a division rule for our a's. And for our b's, we're using the multiplication rule. Okay? So, a to the power of 3 divided by a to the power of 2, we can represent as 1 base, 3 minus 2 as the two exponents. Still be multiplied by b times b to the power of 4. That's 1 base, and we add the exponents, which technically there's a 1 here. So 1 plus 4. Final answer will be a to the power of 1 times b to the power of 5. The other way you could have done this, which pointed out this would have been much easier. We didn't have to technically make our a positive. I could have just collected my like terms right off the bat. Multiplied my a's by each other and my b's by each other because they're all multiplication. So I would have a to the -2 times a to the power of 3 and b times b to the power of 4. We would have got 1 base, a -2 plus 3, and b 1 plus 4, a1, b5. Much faster. Next question. If you guys notice, we have a's above each other, b's above each other. What's the last one, Kieran? C's above each other. So I'm going to use the division rule for all of these 3 pairings. Now technically they are multiplied by each other. But instead I'm going to make this base a negative 4 minus 1. Remember, this a is to the power of 1. B, 5 subtract 3. And C, 2 subtract 1. Again, this is to the power of 1. We'll end up with a to the negative 5 times b to the power of 2 times c to the power of 1. If I ask you to represent it as positive exponents, which I'm pretty sure I'm going to, I want your answer to be in positive exponents only. Right now our a is not a positive exponent, so we'll need to flip it. Remember, a to the negative 5 can be represented as a 1 over a to the power of 5. So we would get 1 over a to the power of 5 times b to the power of 2 times c to the power of 1. And when we multiply fractions, 1 times b squared is b squared, and b squared times c is b squared c. So we'll get b squared times c, a to the power of 5 times 1, a to the power of 5 times 1 again is a to the power of 5, over a to the power of 5. Yes. I will want your answers in positive exponents only.